Welcome back, everybody. Today we're going to be talking about solutions to systems of equations where one is a linear equation and one is a quadratic equation. And we'll also look at how it compares algebraically and also graphically using Desmos. So first one here, question is, how many real solutions does the system have? Well, first of all, let's just talk about the three possibilities that could happen with a quadratic and a linear. Alright, let's say we have a quadratic equation, makes a parabola, and then we have a linear equation. It could do this, where it goes right by it but doesn't touch. It could do this, where it touches just one time and has one solution. Or it could do this, where it touches two times and has two solutions. Let's look at this algebraically first, and then we'll look graphically. We'll set the two equations equal to each other and solve for x. We'll get everything to one side by adding 3x to both sides. If we add 3x here, that'll cancel out the 3x's. We'll also add 3. And that will give 5 and 3 to give us 8. So now we have x squared plus 8. In order to solve for x, I have to subtract 8 from both sides. And then I have x squared equals negative 8. If we take the square root of both sides, we do not have a real solution. So, since there's no real solution, there are zero real solutions for the system. The graph is going to resemble this scenario. Let's have a look at Desmos and look at these two. Here it is, here's the linear, here's the quadratic, and as you can see, you can even zoom out a little bit, they will never touch. They will never touch. Therefore, zero solutions. Alright, let's look at another one here. Here's the graphs that they give us. What are the solutions? This point right here, and the coordinates are 0, 1. And this point right here. And the coordinates appear to be 2, 5 off a little bit. It's not exact, but we'll just say 2, 5. Alright, let's look at these two. What are the solutions to negative 6x minus 6 and x squared minus 5x minus 6? Alright, we're going to add 6x to both sides. 6x and 5x make 1x. We're going to add 6 to both sides. 6 and 6 make 0. So here we are. In order to solve this, I'll use factoring. X times x plus 1 is equal to 0. So two things are true. Either x equals 0 or x equals negative 1. And I can plug 0 and negative 1 into either equation to find the total coordinate points there. So for this one, 0, let's plug 0 back up here in the first equation. Negative 6 plus 0. Negative 6 times 0 is 0. 0 minus 6 is negative 6. Y is negative 6. That's one coordinate point. Negative 1, let's say if x is negative 1. If I put negative 1 up here, negative 1 times negative 6 is 6. 6 minus 6 is 0. So there's those two solutions there. Let's have a look at Desmos. Alright, here's negative 6 minus 6, and here's x squared minus 5 minus 6. Let's zoom in a couple times and see if we can verify. Yeah, there it is. There's 0, negative 6. And then here's another coordinate point where they intersect, negative 1, 0. Kind of hard to see at this link. Let's zoom in a little bit further. We can see the two separating right there. Negative 1, 0. Negative 6, 0. Alright, let's look at another one here. What's the solution to this system? Negative 2x plus 4, x squared plus 4x plus 13. Again, set them equal to each other. And let's get everything to one side. We are going to add 2x to both sides, and that'll give us 6x. We will subtract 4 from both sides. That'll give us 9. Turns out we have a perfect square trinomial here, and that factors into x plus 3 quantity squared. And then solving this, take the square root of both sides. We get x equals 0 equals x plus 3. We solve for x equals negative 3. To find the y coordinate, go back to the first equation. Negative 2 times negative 3 is 6. 6 plus 4 is 10. And let's swing back over to Desmos and see this graphically. Negative 2x plus 4, x squared plus 4x plus 13. There we go. Looks like we are crossing only one time. Right there. Yeah, negative 3, 10. There it is, right there. Negative 3, 10. Alright, we've got a story problem to do. Bike repair shop's revenue in dollars can be modeled by this equation. Y equals 400 plus 220x, where x is the number of hours spent repairing the bikes. The overhead cost in dollars can be modeled by this equation. 20x squared plus 160, where x is the number of hours spent repairing the bikes. How many hours does the company break even? Note, the phrase break even refers to the value where the two functions are equivalent. So we're just going to do what we've been doing, set the two equations equal to each other. Get everything to one side. Means we're going to subtract 220x from both sides. Then we'll take away 400 from both sides. 160 minus 400 is negative 240. Alright, this can be solved by factoring. We're going to factor out first a 20 from everything. We have x squared minus 11x and then minus 12. I got those numbers by dividing everything in the equation by 20. And then we can break this up into x and x, and we ask what factors of negative 12 add up to negative 11. Negative 12 plus 1. We have these two little mini equations. We're solving for x equals 12, or x equals negative 1. And x is the time spent repairing the bikes. You can't have negative time, so the positive 12 is going to work. 12 hours. Swing on over to Desmos and see if we can see this graphically. Alright, we'll just look at the home. So we have to zoom out quite a lot to see these. Alright, so looks like we have a vertex down here. Yeah, so we have to play around with it to find it here. Let's see if we can, it looks like we see that on that right side there. See, they're touching here somewhere. There it is, right there. That's where their two graphs are touching. Kind of hard to see graphically, but at 12 hours is that break-even point, where what you make and the cost $3,040. But we can see that right there, x equals 12. All right, thank you for watching. Hopefully this helps your understanding when you deal with a linear equation and a quadratic.